If I were to draw the Earth here, where do you think the moon should go? Here? Over here? How's this? The answer is that the moon is about 384,500 kilometers away. But what does that look like? The human brain is great at many things, but assigning astronomical distances to mostly empty space is not one of them. So let's fill that empty space between the Earth and the moon, and we're going to fill that space with objects that we're familiar with, the other planets, and even Pluto can come. But let's make this simple. We're going to use one unit that we understand a little better, and that's Earth. Now, Earth is huge. It itself has a diameter of 12,756 kilometers, or 7,926 miles. But it's probably easier to imagine one Earth unit. That is 12,756 kilometers equals one Earth unit. Now we can begin talking about the distance to the moon. Using Earth units, we can convert the diameter of all the planets and Pluto into Earth units. For example, Mars has a diameter of 6,786 kilometers. Therefore, doing some division, we find that Mars is 0.532 Earth units. Thus, Mars is about 1/2 the size of Earth. We can do this with all the other planets. Mercury, 0.382, Venus, 0.949, Mars, 0.532, Jupiter, 11.209, Saturn, 9.449, Uranus, 4.007, Neptune, 3.883, and Pluto is 0.18. Now that we have all the planets plus Pluto in Earth units, we can simply add them all up and we get 30.591 Earth units. Then we can multiply the total Earth units by the diameter of one Earth, which is 12,756 kilometers. And we find 390,218.796 kilometers. That is the sum total of distances divided by the number of different distances is around 384,500 kilometers. But the moon is on an ellipse, which at its closest approach is at 363,396 kilometers away. And at its furthest is 405,504 kilometers away, which means at the furthest point we could fit all the non-Earth planets and Pluto in between the Earth and the moon and still have 15,285.204 kilometers, which is enough room to fit a clone Earth and an extra Pluto, plus 233.124 kilometers. At closest approach, we are 2.1 Earth units too large to fit all the planets and Pluto in between. Which means if we divide the Sun's diameter by the number of Earth units that we have, times the diameter of Earth itself, we find that we could fit the aligned planets inside the Sun 3.436 times. Now if we took what I'm going to call the celestial body ruler, CBR, not to be confused with the cosmic background radiation, it would take 369.14 celestial rulers to reach the Sun. How many kilometers it is to the Sun, I leave as an exercise to the viewer. If you were to measure the distance to the Sun with the diameter of the Sun itself, it would take 107.59 suns to reach the Sun from Earth. And this is what we call one astronomical unit. The solar system is vast, and the universe even more so. But maybe that just means we have room to grow. To set you on your way, I give you a final distance in our new ruler. The nearest star is Proxima Centauri in the Alpha Centauri star system, and it is 39.9 times 10 to the 12 kilometers away, which, in our CBR measurements, is 98,452,670.46 CBR aligned planets away. Maybe we just need a bigger ruler.